Hello, my name is Dylan Hamilton, and this is my prototype for my Game 170 class. This is a puzzle game based on deciphering mathematical equations in order to defuse a bomb. Right. So these are the game properties right now. We have the main board that has a list of different mathematical equations on them, along with a few other elements. We have a dial diffuser right here. This game, unlike traditional games, it's based on using like a dial lock pad that you have to rotate the dial in a correct order just to get. These two pieces are ciphers. So we have to use them in order to like gain the correct combination of numbers. All right. We also have additional pieces right here, used for telling when the player has the correct code. So, one way to play the game is that these two ciphers give you different types of numbers. So, the game is based on having rotational numbers and definite numbers. So, the definite numbers are based on these individual numbers that are placed on this dial right here. So, between 1 and 8. Right? The rotational numbers are the amount of times you need to rotate this dial in order to get the right combination. I'm not talking about, you start at 1, you need to rotate 3 times, so 1, 2, 3. No, you need to rotate around the dial 3 times and stop at 1. So you start at 1, rotate 3 times, and you stop at 1. My apologies. 1 second. All right. So, how the game starts is the player is only allowed to use this cipher right here, which is the rotational number cipher. This is the definite number cipher. We put that off to the side for now. All right. The player must use, or there are different patterns around the center hole right here. You must align the center hole with the corresponding symbol for that cipher. All right? So we place the cipher right here and align it. What the player must do is you have to rotate the cipher around and get there are 3 different rows of circles. What you have to do is rotate until one circle on each row is filled or indicating a different math problem. So, as was shown here, it's landed on 3 different math problems. And those 3 are indicated by this one. So, 2.5 times 5 minus 10. 9 times 5 minus 43. 39 divided by 3 minus 10. And what the player must do is solve each of these 3 to get 3 different numbers. So, as by the way, one thing I forgot to mention is that the player has 5 minutes to do this. They are, after all, the idea is for them to defuse a bomb. So they're timed on this to kind of give the process a intense feeling. So, going forward, this is 3. No, you have 2, then you have 2.5. Now, what what the player must do from here on, given these three numbers, is they must solve the first combination. Right? How do we get the definite number, you ask? You may notice that there is a solid number right here, which is 8. That is the first definite number given to you for this puzzle. What we must do from then on is find out which of these three numbers, the three numbers that are 3, 2, and 2.5, are corresponding to this definite number. Now, in order to find which number is corresponding, we must divide 8 by these individual numbers, or rotational numbers, and the result must be a number that is not a decimal. Right? If, let's say, we divide 8 times 3, or divided by 3, the number would obviously come out as a decimal point, because 8 does not go into 3 perfectly. So that is not the corresponding. However, 8 divided by 2, it goes in perfectly 4 times, so that is the corresponding number. So what we do is we rotate to 8. So the starting point is 8. We must rotate around 2 times, so 1, 2. Right? And if the player is correct on getting this, they then get an indicator. So this indicates that you solved one correctly. You solved a combination correctly. Okay. Now, after the first combination is solved, the player then gets to use the definite number cipher. So, doing the same process as the first cipher, you must align this center hole into the symbol. Right? And going through with the same process, you must rotate the cipher until one hole from each of these rows is filled in at the same time. Right? So, rotate this a little bit. A little one-handed, so this is a little tricky, but not impossible. Oh. Well, here we go. Alright. So, notice... Oh, a little bit of wind. Notice how it's not pointing at a specific number at all. It doesn't need to point at the number. It just needs to point at the equation that we're working with. So, the equation that we are now working with is 48 minus 26 minus 12. 21 times 2 minus 37. And 52 minus 64 plus 15. So the player must solve these three again. So this one would be 7. This one would be 5. And this one would be 3. Now, holding on to the same numbers, by the way, since we used 2 to solve 8, we discard that rotational number, so we only have 2 left. We have 3 and 2.5. Now, we use those to solve, or we divide the different numbers by the rotational numbers that we have. What we do, we divide 7 times 3, that's going to be a decimal, so that doesn't correspond. 7 times 2.5 is also a decimal, doesn't correspond. So we move on to the next one. 5 divided by 3 is a decimal. Doesn't. But 5 divided by 2.5 gets you 2. So we now know that 5, or the definite number of 5, has a rotation of 2.5. 3 goes into 3. You get 0. Or divided by 3 is 0. But that's still a number that doesn't have a decimal, so it counts. So we know that the definite number of 3 is has a rotation of 3. So the order of sequence that we then proceed here with these two numbers is that the lowest definite number goes first. So the lowest out of the two is 3. So we do 3. We rotate it once, twice, 3 times. We get a indicator. Yeah, here we go. All right, then we work on 5. All right, so we do 5 once, twice, and here we stop at 1 because 2.5, it's not a full number. And then that's solved. So we get 3. Now, notice how I mentioned an extra definite number, which is 7. Right? What we do, since we have the 3 that we need, the 3 indicators, we then rotate this this dial over to 7. Doesn't matter which way, as long as it gets to 7. And that is when we get the final indicator, the large green, to indicate that the bomb has been defused. And that's how you solve this puzzle and win the game. Within 5 minutes, of course. So it might be challenging. The next few challenges, because this is like easy mode. Next challenges would have more numbers, more problems. Different or not different symbols, but like more of these symbols. So you have to like experiment which ones are the correct outlines. But yeah, that is my prototype for this project. Thank you for listening.